Hello everyone, my name is Kök. I am a researcher at the Technical University of Vienna, and today I am going to present you the calculation module SAPHEA-Geophires. So basically, to access this calculation module, you need to come to the SAPHEA Toolbox, and then you need to navigate to the calculation modules section. As you can see here, since we did not choose any area, all the calculation modules are deactivated. And if you hover over the SAPHEA-Geophires, you can see that it's available at all levels. So you can choose whatever level you like. So for now, I will choose the city of Vienna at NOT 3 level. So then you just need to click and you see the inputs. So one remark here that this calculation module does not directly use any GIS data. So the region you choose will not make any impact on the results for the current version of the model. So coming back to the inputs. So here you can see there is a session name. So basically, if you have a user profile and you are logged in, you can here give a name to your, let's say this is my first run or run 1. So basically this allows you to track your calculations in your user profile. Then here, if you hover down, you will see the inputs. So we have 3 categories of inputs. You can open and close them using these symbols. So basically, we have the most fundamental inputs in the inputs category. And the second one, we have basic inputs, which is a mix of some basic and advanced level inputs. And then we have the most advanced level inputs in the last category. So we recommend to users to start with the first one and go through the last one. But the most important ones are always in the top categories. So going through the input parameters we have briefly. So the first one you have is the reservoir depth. So you can also see that whenever you hover over a parameter, input parameter, you always get an extra text popping up, so give you more information. And for every parameter, you will have a default value that we are providing, but we recommend that, especially for the first category, that if you have your own data, definitely change them. So you can get your own results. This is valid for reservoir depth and gradient as well. Then you can see the minimum and maximum values. If you type a value out of this range, you will get back to the default value provided. So, and you can here see which value is right now given. The second value parameter we have is the gradient. So basically, this gives you the temperature gradient in the hydrothermal reservoir. So these 2 parameters are used to calculate the reservoir temperature in combination with the surface temperature. And we assume that there is a constant gradient within this reservoir depth. Then we have the number of production wells and number of injection wells. So here is the critical part is that these are identical production wells. So the number you give will just create identical wells for production or injection. Then we have the production flow rate per well. Again, here it is critical to note that these flow rates are per well. So for instance, if you have 2 production wells, then you will at the end have 100 kilogram per second of flow rate. So keep this in mind. Then finally, we have the injection temperature in the first category of inputs. And this is the injection temperature of the geofluid injected in the wellhead. Then we have the basic inputs, the second category. So the first 2 parameters in this category are actually some expert level inputs, the productivity and the injectivity indexes. So you can see their explanations here and our default values. So here we give a more or less an optimal default value, but it is highly recommended if you can get any expert guess on these values in your region and try them. Or you can also play around with parameters and see how your results are changed. Then we have the surface temperature. As I mentioned before, this is used to calculate the reservoir temperature in combination with the temperature gradient. Then we have the end-use efficiency factor. So you can think this the constant efficiency of the surface plant. And here we directly assume that we are having a direct use of heating. Then we have the utilization factor. So this is basically the same as a capacity factor. Then we have the lifetime of the plant. This is important to calculate the levelized cost of heat. We have a euro to US dollar exchange rate. So we have this parameter because the GeoPhires tool originally is developed and based on the US case studies. So all the cost functions are fitted for US dollars. So we have here a default exchange rate, but you can always change this to make it more realistic. And finally, we have a discount rate, again, used for the levelized cost of heat calculations. In the advanced inputs, what we have is mainly the cost adjustment factors. So let's say that you run your model and you get your results, and you will see that there is a breakdown of all the cost components. And since these cost components can be different from region to region, so we give you the option that if you have a look at one of these categories and say, okay, in my region, actually this cost is 20% more expensive. So you can basically change this factor to 1.2. Then every time you run with this value, you will see directly in the results that this cost is always 20% scaled up. So this gives you the same options for different cost categories. And finally, we had the electricity rate. Basically, it is the electricity price to calculate the pumping cost. So once you are ready with all the parameters, you basically just click on Run CM, and you will get the results in just a few seconds. Then in this result tab, you see the indicators. So here we provide you some summary indicators to quickly have a look at your results and get the most of the KPIs. So briefly going through this, you will see the heat production capacity, annual heat production, the average production temperature. Then you will see some economic parameters here, such as levelized cost of heat. You will see different cost components for capital cost, and at the end, you will see the total capital cost itself. Then you will see the operational and management cost, and again, the total cost of. And then at the bottom, you will have some more technical parameters regarding to the geothermal reservoir, such as the bottom hole temperature, the pressure drops, the average pumping power used, again, some pressure values and pressure drops. And after having look at this, if you are interested and would like to do more analysis, you can basically click on export indicators and download the exactly same indicators to your local computer. And basically you have a CSV file consisting of all these values. Then we also provide some extra outputs for further detailed analysis. So if you click on export extra files, you will get a zip file here. So after downloading this zip file, you will see there are 4 files inside, 2 text and 2 Excel files. So basically the Excel and text files are the same. So let me briefly show you. In the text files, it's easier to read and go through all the results. So you can have a look at the results here. So in the first Excel file, you have a summary of results and some profiles. In the second text file, you will have a more detailed case report. And at the end, you will have more detailed profiles. And if you would like to, again, do more analysis, so we also provide you some Excel files to make it easier to copy paste your data or directly make some analysis on Excel. So I will just show you one example. All right, so basically this is the same data as in the text file, but it is just categorized into different sheets, and it's easier to copy paste this data or directly do some plotting or analysis. So finally, if you go to the wiki page and click on the calculation modules and come to the SAPHEA-Geophires, you will have a much more detailed information about how to run the model, and then the field values, units, descriptions of all inputs within the same categories. And you also have some descriptions regarding the indicators. So you can also see what each indicator is meaning. And finally, we also have some information about this extra output files. And at the bottom, you will have access to information about a sample run. So how to run this model. So you can also go through this and have a look at how to run the model. So this brings us to the end of SAPHEA-Geophires CM of SAPHEA Toolbox. Thank you for watching.